When we think of AI, we usually picture this giant brain humming away in some distant data center, right? But what if that brain could be right here, in the room with us? What if it had its own eyes and ears, understanding things as they happen, in real time? Well, that's exactly what we're digging into today, a whole new frontier called AI on the edge.
Just think about how we as humans understand what's going on around us. We don't just read a transcript. We see people's expressions, we hear the tone in their voice. For an AI to be genuinely useful in really complex real-world situations, it's got to do the same thing. It needs both eyes and ears.
And that leads us to the central challenge, doesn't it? In places where every single second and every action is critical, I'm talking about emergency response, complex machinery repairs, or even surgery, how can a piece of technology possibly capture the whole picture? Not just the words, but the actions, to actually provide real help when it's needed most. Surgery is the absolute perfect example of this. Real understanding inside an operating room, well, it doesn't just come from what the surgeon says, and it doesn't just come from what the surgeon does. It comes from putting the two together. This is precisely the problem that this whole concept of surgical intelligence is designed to solve. So what's the magic that makes this possible? It's something called multimodal AI. All that really means is that it's an AI that isn't stuck in one lane. It's not limited to just text or just images. It can process multiple modes of data, like your voice in a video feed, at the exact same time. And that gives it a much richer, much more complete picture of what's actually happening. All right, so let's break this down into its parts. We're going to start with the first sense, hearing. Imagine an AI that can listen in on a really complex situation and instantly figure out what's important. And here it is. This is the SI listener. Now, this is so much more than just a transcription app on your phone. It takes a live audio stream, it understands the context, and it turns all that chatter into organized, usable data. And this is the kicker, it does it all right there on a local device. No cloud connection needed. So how does it pull this off? Well, first, it's just ingesting the live audio. But it's smart about it. It uses specific voice triggers to know when to start paying close attention. Then, a generative AI gets to work, figuring out the context of what's being said. And finally, it pulls out all the critical info and organizes it into a neat, structured format. Okay, let's make this really concrete with an example. Picture a field technician inspecting some heavy machinery. They say, "Start recording." As they're working, they mutter, "Looks like we've got a bearing overheating." Now, SI Listener doesn't just type that out. No, it understands that bearing overheating is a defect. It creates a formal maintenance record, and it can even ping a knowledge base to suggest the standard repair procedure for that exact problem. And it does it all instantly. And this whole system is built for speed. Because it's engineered in C++, it chews through audio chunks over 3 times faster than a more standard approach. And in a critical situation, that kind of speed can make a huge difference. It's also incredibly efficient. We're talking 60% less CPU power. That is absolutely crucial for a device that might need to run for hours on a small local machine, not some power-guzzling server in a data center. And on top of all that, it's super lightweight. It has a 40% smaller memory footprint. That means it can run on smaller, more portable hardware, bringing this power right to where it's needed most. Okay, so we've covered the ears. But to get that complete picture we talked about, you also need eyes, right? That brings us to the visual side of the system. And here it is, SI Watcher, the perfect partner to the listener. It takes a video stream, live or recorded, and just like its audio-focused sibling, it transforms what it sees into structured, actionable insights. And again, it's all happening locally, right on the device. So how on earth does it process video without melting a small computer? Well, here's the clever part. Instead of analyzing every single frame, which would be massive, it intelligently samples keyframes at set intervals. A vision-capable generative AI then just looks at those specific frames to figure out what's going on and pull out the important insights. It's about working smarter, not harder. Think about a camera watching a factory assembly line. SI Watcher isn't trying to stream terabytes of video to the cloud. Nope. It's just glancing at a frame every few seconds. But when it spots an anomaly, let's say a part is misaligned, it doesn't just send a blurry picture. It creates a structured alert with all the context and sends it straight to a human operator, making sure an expert is always in control. So we've got the listener and we've got the watcher. Now, each one of these is pretty powerful on its own, but the real magic, the real breakthrough, happens when you put them together.
This is where we fuse those two streams of information. We're talking sight and sound, coming together to create a single, comprehensive understanding of an event as it's actually unfolding.
Okay, so check this out. This is how the whole system works. You've got audio flowing into the SI listener and video flowing into the SI watcher. They're processing their data at the same time, in parallel. Then, the structured data from both of them, the what was said and the what was seen, gets fed into a central GenAI engine. This engine puts it all together into one unified report. It knows what was said, and it knows what was happening visually when it was said. That's the whole ballgame.
Now, all of this incredible stuff is only possible because of one key concept. We've mentioned a few times, doing all this processing on the edge. So let's take a second to really understand why that's such a game changer.
You hear edge computing and it might sound complicated, but it's actually a really simple idea. It just means that all the heavy lifting, all the AI thinking, happens right there on a local device, like a small computer in the operating room, instead of being beamed over the internet to some massive data center hundreds of miles away. And just look at the difference this makes. With edge processing, your data privacy is incredibly high because sensitive info, like surgical video, never even leaves the room. The latency, or delay, is basically zero, which allows for true real-time decisions. And maybe most importantly, it works completely offline. That's a huge deal in places with spotty or no internet. For these kinds of high-stakes situations, the edge isn't just a nice-to-have, it's absolutely essential. So when you combine this multimodal AI, the eyes and the ears, with the sheer power of edge computing, you're not just building a smarter tool. You're actually creating a totally new kind of awareness for our technology. And it all comes right back to this fundamental idea. Whether we're talking about an OR, a factory floor, or an emergency scene, the most important events are multimodal. This technology is built from the ground up to understand the world the same way we do, by putting sight and sound together. I mean, it's a truly incredible leap forward. From giving a surgeon a kind of cognitive co-pilot to ensuring safety in tactical operations, the potential is just vast. And it leaves us with a really fascinating question to think about. When our technology has true situational awareness, right where and when it matters most, what other problems will we finally be able to solve? What new possibilities are we about to unlock?